Welcome to the session 4 of our Unit 3 Financial Modeling course. In session 4 of our Unit 3, we are going to consider diagnostics of independent variables, which is a continuation of our previous session, which also considers the diagnostic stage for independent variables. By the end of this session, you should be able to test the significance of specific independent variables in a regression model and also assess the explanatory power in a model. Specific coefficient values test. We have to understand that we can use the estimated equation to perform hypothesis test on a specific coefficient of the model. So for example, we can test the hypothesis that the coefficient on the bank balance or the bank balance term is equal to 1. We can do so by the use of the WAL test. So, for instance, we have to determine the coefficient of interest by selecting the view. That is, after we have launched our eView application and we have our dataset loaded and also our equation or our model estimated, we have to use the view function or the view toolbar. We have to clear from the equation toolbar note, and we also have to note that the coefficient of the coefficients are assigned in the order that the variables appear in the specification. So like they have been assigned based on specification. So here, as you see, we see C1, which is the constant, C2, which is the first beta coefficient, C3, which is the second beta coefficient, C3 is the fourth, which is gender, C4 is gender, C5 is student status, and C6 is the bank balance. So here we have to understand that in the view section they appear in such manner, so you should not be confused with it, because in the previous session they have different description. So by doing so, we have to test the restriction, or we have to test the restriction that to test the restriction on the C6, which is the bank balance. We select the view toolbar and also select the coefficient test, and then finally we have to select the WAL test, which is the test that is going to help us in estimating the restriction, and enter the restriction, which is the C6, because this is what record, or this is what calculate the bank balance in a snapshot. So after that, then the C6 will appear in this additional box, which we are just simply saying that this is equal to, or the BL term is equal to 1. We are simply testing as whether it is true or not. So we click OK after this. Table 3.6 below this table reports the result of the WAL test for the BL test. That is, we are testing as to whether the BL coefficient is simply equal to 0. So here our focus will not be on the upper part, but we will focus on the p values, where we had 0.000, which indicate that at least we had 0.00% proof that this value is significantly different from 0. So the 0p value indicates that the null hypothesis that C6, which is the BL or the bank balance portion or the parameter, is equal to 0, and therefore we reject that. We strongly reject that hypothesis. So in short, the WAL test is mostly useful in tests of such nature, because it's used in testing for elasticity and also in testing for growth models, among other tests. The F statistics of explanatory power. Like the coefficient of determination, the F statistics test of explanatory power is also used in testing for the power of the regression line. So by using the best value of the adjusted coefficient of the determination, that is from our previous table, that is table 3.4, we are simply inferring that about 97% of variations in the credit rating, which is the dependent variable of the regressor, can be explained by the variations in the regressors, that is in income level, student status, and bank balance. But questions such as, by how can we get this outcome, is 97% too high, too low, or just right can only be assessed using the F test of explanatory power. So for instance, if we want to draw inference about whether or not our R square, which is the coefficient of determination, is significantly different from 0, we can use so by testing, or we can test so using the F statistics test of explanatory power. So then we can test whether or not the slope parameters, that is the beta coefficient, are jointly equal to 0 using the F test of explanatory power as well. We can make such decision by using the p-values, as they are now widely used or widely reported in most statistical and econometric packages. So most of the recently developed econometric packages are simply reporting p-values, and mostly they are used in testing for some of these diagnostics. The equation below represents the hypothesis test, and so the previous hypotheses that we were estimating are being tested using the equation below. So equation 3.18 test as to whether the R square is equal to 0 or the R square is not equal to 0. So as to whether the R square is significantly equal to 0 or not. So the null hypothesis is in the form R square equals to 0, and the alternative is in the form R square is not equal to 0. You can observe that equation 3.10 is equivalent to testing the hypothesis that all the slope coefficients are 0, and also we can see that all this hypothesis lies outside our equation. So equation 3.19 is testing whether the slope coefficient or the parameters, that is b1, b2, b3, are significantly equal to 0 or they are not. So the null is simply saying that it is not, and the alternative is saying otherwise, or is saying that it is the case. So the formula for the F test statistic is defined as in equation 3.20. Using the typical 5% significance level with a p-value threshold, that is with a 95% confidence interval, what we are saying that if we use 5% significance level, then we are saying that we have 95% confidence that our model or our test statistic is significant. And also establishing a p-value of 0 and an F statistics of 4963.955. This was the F statistics that we achieved in our table 3.4. Then using all these parameters or using all these diagnostics, then we failed to accept the null hypothesis that all the parameters are simultaneously 0. So from our previous model, we saw that we estimated that all our slope coefficients are significantly not equal to are significantly 0, or they are equal to 0. So by this test, we can use the F test of explanatory power to prove that this value is significantly not equal to 0. We hence conclude that the model can capture a significant proportion of the variability in credit ratings, and this also conforms to the independent test that we perform in our equation 3.22. In summary, we have learned to test the significance of specific independent variables in our regression model, and also we have learned to assess the explanatory power of the F-test statistics in this model. Thank you for your valued attention as we come to the end of today's discussion. I hope to meet you once again in our next session. Stay blessed.